In the previous video, I showed you how two forms, the Vesica Piscis and the torus, could be extrapolated from the patterns formed. I will now show you some more extrapolations, and hopefully it should become clearer to you just how special sacred geometry can be. As before, I am going to be using the two-dimensional pattern to demonstrate to you various things, as it is far easier to comprehend than a fully three-dimensional pattern. You must realise, however, that the actual pattern is fully three-dimensional, and this should become apparent to you shortly when I discuss the Platonic solids. After the tube torus and Vesica Piscis, the next thing that can be demonstrated is known as the tree of life, derived from the seed of life pattern. It is most commonly recognised as a mystical concept within Kabbalah, and is a motif in various world theologies and philosophies. In Kabbalah, it is used as a tool to understand the nature of God and the manner in which He created the world out of nothing. The details of this particular study are too complicated to overview briefly at this point. The next form that can be extrapolated is known as the egg of life. If we proceed to the second vortex motion as described in the previous video, and remove all the circles from the seed of life except this central one, we create this new form consisting of 8 spheres. This form is three-dimensional, and from our two-dimensional perspective we are unable to see the 8th sphere, which is located behind this central sphere. This pattern is the most balanced and optimum form for 8 spheres existing in direct connection with each other. The reason why it is called the egg of life is because nature uses this form in the embryonic creation process of every single living organism on this planet, with no exceptions. Nature chooses this form because it is the most balanced, most harmonious form possible. We now proceed to arguably one of the most important set of extrapolations, one which can demonstrate visually as well as mathematically the beauty of sacred geometry. If we take the fruit of life layer defined in the previous video and extract these 13 circles, what we get as a result is known as the holy archetype, Metatron's cube. This can be imagined as an extension of the egg of life, as there are 8 spheres in this central portion, but also an additional sphere attached in perfect alignment to the corner of each one of the 8 central spheres. In total, there are 16 spheres in the three-dimensional version of Metatron's cube. It is interesting to note that the parameters of a hypercube, also known as the terasect, can be extrapolated easily from Metatron's cube, and for this reason literally adds another aspect of dimensionality to this particular form. This arrangement of the spheres is geometrically perfect, so adding or subtracting spheres as previously hinted at with the transformation from the egg of life to Metatron's cube has no impact on the integrity of the geometry itself. For this reason, you should be able to now comprehend the holographic idea as mentioned at the end of the previous video. We have just hinted at a fourth-dimensional concept from a three-dimensional structure. However, as we cannot directly perceive a fourth dimension, there is little else to mention on this topic at this point. The most widely recognised aspect of Metatron's cube, however, is its relation to the Platonic solids. It should be noted that although Plato's name is attached to these forms, it has been discovered that the late Neolithic people of Scotland had Platonic solid ornaments made of stone 1,000 years prior to Plato. This obviously creates a big question of where they got this wisdom from, but that is for another line of inquiry, another video series. There are 5 Platonic solids: the tetrahedron, the octahedron, the hexahedron, the icosahedron, and the dodecahedron. What makes these shapes so special is that the faces, edges and angles are all congruent, and that each one can fit perfectly inside a sphere with all the corners touching. There are no other shapes in existence which satisfy these conditions, and that is what makes these shapes so special. These 5 Platonic solids also form pairs, known as duals. The hexahedron and the octahedron make up one pair, and the icosahedron and the dodecahedron make up the other. The tetrahedron is the odd one out, as it is a dual with itself. What this means is that one can be created inside the other, known as nesting, by connecting all the midpoints of all the faces. This process can be repeated to infinity in either direction, and demonstrates very clearly the idea of symmetry in a very unique way. It is also possible to nest each Platonic solid within the other 4 without error, however the symmetry is not as perfect as it is with the duals. So, how do the Platonic solids relate to Metatron's cube? If we take the two-dimensional form of 13 circles for the sake of simplicity, and using straight lines connect the centre of every circle to the centre of every other circle, we end up with this pattern. What this has created is the parameters for the two-dimensional flattened versions of the Platonic solids, with the exception of the dodecahedron. The dodecahedron is special in that it requires one to rotate the three-dimensional version of Metatron's cube by a ratio of phi in order to reveal the missing lines. However, one can add the additional lines on the two-dimensional version by dividing these sides by the golden ratio and adding in the extra lines accordingly. It is perhaps for this reason that Plato and Pythagoras shielded others from the dodecahedron, as this particular aspect of wisdom is quite unique, and maybe they felt it would reveal too much if taught. Each Platonic solid is also associated with an element, although these connections I consider to be subjective at this point. The ether, for example, is known to be a formless, omnipresent, immaterial substance, and thus being associated with a geometric shape doesn't quite work. It has been postulated that the dodecahedron is actually associated with the heavens, or cosmos, and interestingly, cosmologists in France and the US suggested that the universe may actually be in the shape of a dodecahedron, based upon their study of the cosmic microwave background radiation. There are some extra shapes which can be extrapolated from the 5 Platonic solids. These are known as the Archimedean solids, of which there are 13 in total. 7 of these can be obtained by truncating one of the Platonic solids. Truncating essentially means cutting off the corners of an existing shape to reveal a new face for the previously existing vertex. 2 of the Archimedean solids can be attained by the opposite process, expanding the Platonic solid. The final 2 are created by snubbing a Platonic solid, which is done by moving the faces outward whilst twisting. These shapes and the processes just described require more explanation, but I do not have enough time in this video to do so. I have saved this final extrapolation for last because it will lead on to the next chapter in this video series. It is known as the divine proportion, or the golden ratio, and like the mathematical value of pi is an irrational number, this means the exact value can never be fully determined, as the creation of this number results in an infinite series of non-repetitive digits. The most simple way to demonstrate the golden ratio is to use the Vesica Piscis layer of nature's first pattern, although there are many other opportunities to demonstrate it, such as with the Platonic solids. I will now show you the process of calculating the golden ratio from the beginning. We start with a single length with the value of 1, and using this as the radius, we trace a circle. The diameter of the circle obviously has a value of 2. The next step is to simply create another circle of identical size with its central points located anywhere on the circle defined previously. This creates the Vesica Piscis shape as explained in the previous video. If we add in some guidelines, the rest of this calculation should be very easy to comprehend. We can now construct a simple right-angled triangle using the values of 1 and 2, 1 for the height and 2 for the width. The hypotenuse length can be calculated using trigonometry. Using this length, which has a value of 0.5, we rotate it around this point to trace another circle. Where this circle intersects the hypotenuse, we have the final parameter for the golden ratio, which is this newly created length along the hypotenuse. We have now successfully demonstrated this geometric relationship, known as the golden ratio, and have an approximate number of 1.618 as its value. This can also be used to construct what is known as the golden spiral, and is most commonly recognized in the Nautilus shell. The golden spiral can be approximated using a series of numbers known as the Fibonacci series. This relationship is an aspect I will be mentioning in the next video, where I will show you sacred geometry in the biological world and how nature utilizes these forms and principles to give rise to the symphony of life we see all around us.